Hey everyone, welcome back. Today we're going to look at rationalizing the denominator. If you've completed this previous videos, mixed and entire radicals and radicals multiplication, then today's lesson will be a lot easier for you. So all variables in this lesson represent positive numbers. And let's get started. So first thing I would like to ask is, what would you rather add? These two numbers together or these two numbers together? Right? These are easier to add together. So when we rewrite them differently so that there's no radicals on the bottom, we call that rationalizing the denominator. We're going to get rid of the radicals that are in the denominator. So let's get started. Example 1. Rationalize the denominator. So here we have 4 over root 3. And we want to get rid of this root 3. So what we're going to do is go times root 3 over root 3. Right? This is just 1. We didn't change anything. And then we're going to go root 3 times root 3 gives root 3 squared, which reduces to 3. So here we had a radical in the denominator, and then we got rid of it, and we rationalized the denominator like that. B, root 6 over root 5. So we want to get rid of the root 5. So times root 5 over root 5 like that. This gives root 5 squared, which reduces to 5 like that. And on the top, we have root 6 times root 5, which gives root 30. C, 2 over root 7. So we go root 7 over root 7. This gives 2 root 7 over root 7 squared. This cancels to be 7 like that. D, 1 over root 2. So times root 2 over root 2 like that. This gives root 2 over root 2 squared, which becomes root 2 over 2 like that. Okay, E, here we have 3 over cube root of 2. Now if we went times cube root of 2 over cube root of 2, we would get cube root of 2 squared. And this doesn't cancel. So what we're going to do is actually go times cube root of 2 squared, so that when we multiply, we get cube root of 2 cubed. And 2 cubed to the cube root cancels to 2 like that. Okay, another example. F, cube root of 25. So that's the same thing as cube root of 5 squared. We need a 5 so that we have 5 cubed like that. So we're going to go cube root 5 like that. Multiply cube root of 5 cubed times, and then on the top, 7 cube root 5 like that. Cube root of 5 cubed cancels. What's left is 5 like that. Okay, practice number 1. Rationalize the denominator. So go ahead and pause the video and answer that. We got from A to E like that. Okay, and a couple more. F on the bottom like that. Go ahead and pause the video and rationalize that. Okay, let's correct it together. So 6 over root 5, so root 5 over root 5 like that. This gives 6 root 5 over root 5 squared, which is 5 like that. B, 7 over root 3, so root 3 over root 3 like that. 7 root 3 over root 3 squared. Root and square cancels, so we get 3 on the bottom like that. C, 12 over root 6, so root 6 over root 6 gives 12 root 6 over root 6 squared, cancels and gives 6 on the bottom. Here we can go further. 12 divided by 6 gives 2 like that. D, root of 5 over 2. This is the same as root 5 over root 2 like that. Times root 2 over root 2, so root 10 over root 2 squared cancels out to root 10 over 2 like that. E, 8 over cube root of 3. So we want 3 cubed, so we're going to go cube root of 3 squared, top and bottom like that. This gives 8 cube root of 9 divided by cube root of 3 cubed, which cancels to be 3 like that. F, 2 over cube root of 4. So this is 2 over cube root of 2 squared. We need a 2 in there, so cube root of 2 like that. Cube root of 2 cubed cancels to be 2 on the bottom, and what's left on the top is 2 cube root 2. 2 over 2 cancels, so we have cube root 2 that's remaining. Okay, let's look at another thing that's very common that we're going to use. It's called conjugates. It's very easy. Here we have an expression 3 minus root 2. The conjugate is 3 plus root 2. 6 plus root 7, conjugate is 6 minus root 7, right? You see this difference here like that? Root 3 plus root 2, the conjugate is root 3 minus root 2. Root 5 minus 9, conjugate is root 5 plus 9. A plus B, conjugate A minus B. Okay, it's time for some practice. Practice number 2, determine the conjugate of the given expression. Go ahead and pause the video and answer that. Okay, we're back. So very easy. 5 plus root 6, 5 minus root 6. Root 3 minus root 8, root 3 plus root 8. Negative 3 minus root 7, negative 3 plus root 7, right? It's only in the middle that changes. The first negative remains. 10 minus root 2 is 10 plus root 2. 6 plus root 12 is 6 minus root 12. So we're going to use the conjugate in rationalizing these kind of denominators here. So 4 over 5 minus root 2, we go conjugate divided by conjugate like that, right? So 5 plus root 2 is the conjugate, so we multiply like that. And now we distribute. 4 times 5, 20. 4 times root 2, 4 root 2, like that. 5 times 5, 25. 5 times root 2 is like that. Negative root 2 times 5, negative 5 root 2. Negative root 2 times positive root 2 is written like that. So here we have 25 remains. 5 root 2 minus 5 root 2, this cancels out to be 0. Minus 2, like that. Root 2 times root 2 is 2. So now we have 20 plus 4 root 2 divided by 23. Okay, B. 3 over 1 minus root 7. So we're going to go times conjugate divided by conjugate like that. So 1 plus root 7. 3 times 1 plus root 7 like that. On the bottom, 1 times root 7, negative root 7 times 1, and negative root 7 times positive root 7 like that. Root 7 minus root 7 is gone. What's left is 1 minus 7 like that. This becomes negative 6. 3 divided by negative 6, so this is 1 divided by negative 2 like that. And so we have 1 plus root 7 divided by negative 2. Okay, time for some practice. Practice number 3, A, B, C, D. Go ahead and pause the video and rationalize the denominator. Okay, we're back. A times the conjugate, so 2 plus root 3 over 2 plus root 3 like that. Multiply the top, 5 times root 2 plus 3 like that. We can distribute that to be 10 plus 5 root 3. On the bottom, 2 times 2, 4. 2 times root 3, 2 root 3. Negative root 3 times 2, negative 2 root 3. Negative root 3 times positive root 3 is like that. So this is 4. These cancel to be 0, minus 3. So 4 minus 3 is 1. So what's left is 10 plus 5 root 3. Okay, B times the conjugate, so 1 minus root 5 over 1 minus root 5. We're going to leave it as 6 times that for now. Distribute 1 minus root 5, minus 5 root 5 like that. Or minus root 5 root 5. These cancel out to 0, so what's left is 1 minus 5 like that, which gives negative 4. 6 and negative 4, we can reduce that to be negative 3 over 2, and so that is our answer. Okay, C. Conjugate, root 3 minus root 6 over each other like that. So 1 times this, so it remains. Root 3 times root 3, there you go. Root 3 times negative root 6 like that. Root 6 times root 3 like that. Negative root 6 times root 6 like that. So this becomes 3. These cancel to be 0, minus 6 like that. 3 minus 6 is negative 3. And so what we're going to do is times negative 1 top and bottom. And so this becomes root 6 minus root 3 over 3 like that. Okay, D, conjugate, root 7 plus 2, 2 root 7 plus 4 like that. Root 7 times root 7 times 2, negative 2 times root 7, negative 2 times 2 like that. This is 7, these cancel out minus 4, and so we get 2 root 7 plus 4 over 3. And that's it. It's that easy. I'll see you guys in the next video.